Oh yeah, real time. Doing more quickly than the other days. It is time to solve 6.8. But first, there is some text that I haven't read it, and I'm going to read it in front of you. Okay, nesting state actions. A pattern is beginning to emerge. We are progressing toward implementations that don't explicitly mention or pass along the RNG value. Pattern is beginning to emerge. We are progressing toward implementations that don't explicitly mention or pass along the RNG value. The map and map2 functions allow us to implement in a rather succinct and elegant way functions that were otherwise tedious and error-prone to write. But there are some functions we can't write in terms of map and map2. One such function is non-negative less than, which generates an integer between 0 inclusive and n exclusive. Def non-negative less than n int. Okay. Inclusive, exclusive. A first step at, at an implementation might be to generate a non-negative integer modulo and def non-negative less than n in math non-negative in. It will certainly generate a number in the range, but it will be skewed because int max value might not be exactly divisible. Mhm. So numbers less than the remainder of that division will come up more frequently. When non-negative, uh, when non-negative generates numbers higher than the largest multiple of L that fits in a 32-bit integer. We should retry the generator and hope to get a smaller number. We might attempt this. Retry recursively if the int we got is higher than the largest multiple of n that fits in a 32-bit int. Okay, no negative less than, maybe not negative, one, okay, if I plus 0, then what else? Non-negative less than n, and there is some question marks. Well, if this guy puts, uh, if this was a part of an exercise, I would be totally lost. Like what is he talking about? Yeah, this is moving in the right direction, but non-negative less than and has the wrong type. Remember that it should return a run int, which is a function that expects an RNG, but we don't have RNG value to pass to the result of non-negative less than n. Non-negative less than n there. What we would like is to chain things together so the RNG that's returned by non-negative n is okay. Here's the thing. What we would like is to chain things together so the RNG that's returned by non-negative in is passed along to the recursive call to non-negative less than. We could pass it along explicitly instead of using map like this. Well, well, well here two, yes, non-negative int, yes. Well, mod. We will have to study this function because I'm not like a mathematician to see at first at glance what's going on here. We will try. We will exercise two numbers. Val mod equals I module n if I plus n minus one minus mod greater than or equals to zero, then we are returning this. And if it doesn't, we are passing this RNG2. But it will be better to have a function that does this passing along for us. Later map, nor map2 will cut it. We need a more powerful function. Flatmap. Yeah, this this one comes over and over again. And all of a sudden you're being asked to implement it. Implement flatmap. You know what? After solving this, if we manage to do it, I'm going to put this thing in this so-called generative AI, and describe this type, not be, and ask to write flat map. And of course, it will do it because perhaps those models are being trained with the data available on GitHub, which contains the source code for the answers for this book. So there is no such a thing as intelligent uh, things. It's all about search problems. But we are searching for answers. We humans are also just searching, and classifying. I think I'm going to write a book in which I say, write this function. I'm kidding. This book is amazing because if you see the section, the answer section, my God, it's like lots of hints. And in the official GitHub repository, there are hints prior for you. Even if you don't want to see the answer, you can see a hint before taking a look at the answer. So let's have fun with flat map. And first, let's understand this problem because this motivation for flat map to see what we are trying to do here and not just blindly just you know inventing making up problems. This okay, non-negative less than n. Okay, let's choose 9. Non-negative less, here it says non-negative less than 9. Okay, and they give us nothing but the number, and we are returning a run in, which is a function that accepts an RNG, and uh, then we ask for a non-negative int. Let's suppose this thing give us 16. So I will be again this number one. Sixteen. What else? Okay, we are here. I equals 16. And then we say mod it equals is equals to I modulo 9, which is 7. Do you think it's alright? Do Python? Okay, let's use Scala. The real of Scala. Okay, 10 module 0. So 16 module 9, 7. We were wrong. So mod is 7. If I 16 plus and minus 1 you take it on minus not is greater than 0. We got again this is 50, so this will be 1. So this checks, and we are returning mod, which is 7. You know, I'm going to delete all of this. So now let's choose 5. Okay, so I 5 I modulo 9 is 5. Yes, I know my mathematics a little bit. Can't believe it. Mm, mm, mm. If I plus, I don't think I got the previous answer right. It was it was 16 plus 9 minus 1 was 8 minus yeah, I don't know. Let me. I don't know. I'm not thinking. What's happening? I think I am. Okay, let's repeat the exercise 9. Okay, so let's negative sign. Sorry for this. I don't know what's happening with it. So I is equal to 16 and not probably it's a mindset because I entered to this live session thinking that because I saw this problem yesterday, the, like the name of the function, and I thought, oh my god, this flatMap is difficult. So perhaps I am in the mindset of wasting time, hoping for the hour to end, and just say to you at the end, okay, so we will have another extra video, then take my time. So I'm studying myself with these videos. I'm learning about uh, my mindset with certain problems, which is good. I when I started this series, I didn't thought about how it will help me to recognize certain weaknesses. Okay, mod 16, mod 9, this is 7, and then 16 plus n. Where is n? Okay, 9. Minus 1, that's 8. Minus 7. This is equals, this is all some elixir always, to 15, which is 31. And still, 31 is greater, there you go, is greater than 0. So we're returning mod, which is this. Okay, we got it. Now let's bring negative. No, 9. So I haven't doing. Okay, 9. It is going to take us 2 hours. So 9. But now let's see. The problem is that we I don't know how this guy is. This will never bring a negative in. Let's suppose it brings. How can we reproduce this thing? Let's bring -9. Okay. It doesn't have any restriction over here, right? This could arrive over here. Now, let's suppose E is 5. Now, mod is minus, uh, minus, my God, 5 module -9. It should be 4. 5 because of the negative. The 0, it traverses it goes through of the 0. Hopefully, some line, and this goes, it goes through the 0. Yeah. That's why the field is swiping here, so I'm not getting something. I'm not getting something here. So let's be even more specific or explicit. When I don't understand something, I go to the very basic stuff. This is 10. This is 2. Here goes a 5. It goes out 0. It's a little more specific. Okay. And in here, 16. 9 is 1. Here's our 1 from here. Now, these two. Oh, yeah, I got it now. You need to, Leslie Lamport is right. You need to write it in order to think. Now it's obvious. This is the this is the module. So V is 5. Modulo is 5. And then we have this. I don't know. Maybe I will suspend this live streaming because I don't know what's happening with me. I5 and then and n minus 1. Remember n was this. So we got this minus modulo is equal to 20 minus 20. I think in here there is the infinite loop if there's and it isn't a negative value. This session should be entitled Studying the book instead of solving the problem. It will be more adequate. Oh my god, no, I don't want to be right now. I have this like backup file. Let's see if Scala likes it. Okay, now let's try non-negative less than 9. Oh my god. Do we have an RNG over here? Okay. You see, you saw this in our drawings over here. But now I was thinking minus 9, it's like an infinite loop, but it doesn't. It is still 7, which is wrong because 7 indeed is non-negative, but it's not less than minus 9. So I was thinking there would be an infinite loop over here, but something happens way here. But this is wrong. This is a wrong answer, in my opinion. But let's move along and ignore this. We all make mistakes. Okay, but it would be better to have a function that just is passing around purpose. Later map, no, map to records. We need a more powerful function in flatMap. We implement flatMap and then use it to implement a negative function. Oh, this is amazing. I am doing this. I don't know. Look at this, 32 minutes. No code whatsoever. Um, you see, we have some previous code. I record, recorded some attempt to do this in a time recursive fashion, but this thing is, of course, reversed. So there will be another video in which I'm going to reverse this result because now I am curious how to do this. Let's put this thing over here so the abstract stuff is together. Let's place not to over here. Let's run this thing. Okay. This casty is like very good. Look at this. Look at it. I was asking myself earlier how did they manage because this is a web page. How do they manage to do this? Look at this. You're selecting over here and how do I mean in terms of JavaScript, right? How is this another element, HTML element? Is this only a string, a paragraph? And they are selecting this another thing. Run. Look at this. How do they accomplish this using web technologies? What was? Let's see. I don't know how do they do this. Well, these guys are indeed experts in programming languages. So I don't know how do they accomplish this effect. Yeah. So yeah, let's go back to this. Where are we? Okay, we have a flat map, a B, and an R, which is a rand, and a function F to a rand B. I don't know. I don't know. I'm lost. Let's plug this. We spent 40 minutes just reading the problem. Probably I should read the problem on my own and then just come and do the live session, but I don't want to do that. This is what's really happening. This is the thing. Okay, so when we have a map with a rand and a function and a function from f and a function f from a to b, and we want a rand b, and we need to what we do since we want a rand b, we put this expression over here, function expression, and then apply uh, s to the RNG, this one. We are getting another one, and then apply the function to the value and return this. Now we plus, but let's suppose we get the thing right, you know, uh, like type checks, but we don't know if the definition will be correct. So they need a rand b, and they are giving us a function f from a to rand b. So somehow in here we are just getting a to b, we are getting a b. So somehow we needed to come up with this function expression because we need to like wrap this b in the rand. Now we are getting a rand b. Perhaps this is the rand b that we need to return. So perhaps in here we don't need this RNG. Perhaps. Still, if we have an R, this one, rand of A, like an S, we need a way to apply it to something so we can get our A, you know? So we can get our A. Otherwise, I'm not sure how we can obtain it. So we need something to apply. So let's keep this thing. Hopefully you understand. Hopefully I'm making myself clear. Now we can apply R to this stuff. And we are going to obtain some tuple. Uh, A, let's call it A, and energy 2. Yeah, let's keep it. Now we need to, apply this F to this A, but I'm not sure how we are going to put this thing into place. Let's apply it again so we can see the type. Okay, apply. So we are seeing in the hint that we did have a and we are returning around B. That's the type signature. Let's see if this compiles. But I'm not sure about the RNG2. Ah, we got an error. Look at this. Found playground run B. No, this is heavy. Let's see the time. I wasted too much time on the reading, so we are even having an extra half an hour because of the reading. And then I'm going to exercise. But this is right. We are we are we are founding the compiler is founding a run B, which is this is the run B. F of A equal to run B. We need a tuple because we were asking ourselves how this thing will come into place. RNG2, and it's here. It's here. So let's put this thing over here. Sorry. Uh, this is the RNG2, which is of type. What's this thing saying? Playground RNG. This is RNG. Now we have one component. What else? Now we need a B. Now we need a B. What do we have over here? Okay. This thing is finding a playground run B. Let's do this and apply the function to A. And now we got the term B and 3. Now please compile. No? Okay. This is even better because we have one warning. And what's this? Okay, what's this? Now I'm kind of lost. Let us apply a G2 and it compiles. It type checks as we said before. But now let's hopefully you're getting this. If you're going this far, it's almost the hour. Uh, if you have waited all this time, first of all, thank you very much. And this is the thing. Perhaps I will make some extra videos with little videos, 3 minutes in which I explain this. It will be better instead of having these long sessions. Okay, so in the first place, they want you saw the thing. They want a run B. We were hesitant, so we started applying f of a, and the compiler, you know, these people, Martin Odersi and all these guys are amazing. So the compiler helped us, and uh, it said, we don't, that's not quite right. And we started to make the compiler happy by some tinkering, to be honest. And then we put the RNG, then a RNG2 we apply because we need to apply it. So this R is waiting to be applied to anything, to RNG, sorry, so we apply it. And then we just saw what we did. F of A, which if you're an expert, you will say, oh my God, this guy is clueless. You you didn't despair. Uh, You waited till the end. The compiler said, like I want to be here, and I want an RNG by its own here. So we make it happen. We put F on F of A, and the compiler is still saying, no, man, no, you're not getting away with this. But we remember that we have an RNG too, and if F of A, we have an A. Look at this. If F of A, it's giving us a run B, and run B is expecting to be applied to RNG, and we have one. So with Korean, we say, okay, be happy, and then we obtain our answer, and the compiler at least type checks. Hopefully, now it is time uh, to put this into practice with this thing. Where is it? This guy is amazing. Implement flatMap. Okay. and then use it to implement non-negative less than. I remember 2015 taking this training FP 101X taught by Dr. Eric Meyer, and in the forums, oh my god, people were like, it was amazing, the forums for that class, for that training course. At some point, some people were saying, hopefully you are not being obligated to do this, someone is not pointing a gun on your head for you to do this, and you are doing it because you love it. Do this because you love it. I myself, I'm not sure about if I love this stuff, but I don't know what else to do. I need to exercise. I am losing weight, uh, and I'm very happy with the results. So I want to continue. Now I am motivated to continue, and I can be exercising. I can be playing the guitar. I can be studying mathematics. But at the same time, I like to share this programming stuff, especially these days in which some people are saying it is the end of programming. Machines are generating code. That's cool. Are you able to write code and solve problems? Do it because you love it, and perhaps even if you're unemployed, it will be like a pastime. And if you are rushing to the market to deliver a product, then use the generative AI tools, generate the code, generate the final product and deliver it. But if you want to, some pastime to, some hobby to cultivate, this is a good one. And it can keep you busy, keeps you busy for like hours. And you can, you know, talking to the emptiness. But I am talking because perhaps in the future someone will see these videos. I'm reading some books written by Helfman, Israel, Moisevich Helfman, 50 years ago, 60 years ago, 50 years ago, around 50 years ago. And probably at that point the guy didn't know that 50 years later some guy will be reading this book. So I don't know if 50 years later someone will be uh, surrounded by robots and trying to have a good time solving functional programming stuff and looking in the past if someone was in the same frequency, you know. That's the reason, the real reason I'm making these videos for. Hopefully this intellectual endeavor keeps with the humans like forever, even if it's only a hobby. It is a good one, just like mathematics. So, okay, implement flatMap. And then after the speech, unsolicited speech, which was procrastinating about this, to be honest, and then use it to implement non-negative less than, which is here. And now we are in trouble again. Now we have this powerful function. Oh my god, I don't even know how to start. This is a problem on its own, and it will take me an hour. So let's put some time limit, 10 minutes, 15 minutes, and if we don't make progress, that's okay. I am very grateful, very happy with me to be able to implement this one, uh, especially this smart hard, that's like asking for validation. I don't know.
and use it to implement non-negatives less than. I'm not sure if we need to come up with our own version or if the author wants us to take his function and refactor to use flatMap instead. Let's try to refactor first because you know. Okay, let's print non non negative less than 9. Okay, now what? None. Okay, okay. Def no negative less than and int oh my god int equals. Okay, now the guy said we need to use flatmap. This is hard. Now we hit the end of the hour. We can safely say bye and make an extra video of this. Like a recorded version, a record video, record. Like not live, but extra video. But if we continue to do that, we are solving half the problems. We are solving the entire book, but half some problems are not live. For example, we didn't uh, we didn't implement these internal signals. I want to see the answer because I didn't want to solve this. I didn't understood this part, to be honest. And if I didn't understood, why will I uh, spend 5, 6 hours? It's not clear to me what the thing is with this. These are repetition, and these are very different numbers. So I want to see the answer here instead. So I'm not feeling bad about that. And in here, we implement flatMap after a long chit chat, and then non-negative less than. Perhaps I will say after. Let's give ourselves 15 minutes. Okay. Oh my God, it's very dark already. I don't know how to even start. But okay, flatMap, plant. I don't know. Let's start writing flatMap, and it accepts or expects non-negative in. I mean accepts a run.
Problem. Okay, non-negative in RNG, but we have this thing uh, in map in here. Non-negative in and its map. Non-negative in is the okay, map negative in level. So map is accepting a run of A, and this is indeed a run of A. Okay, here they are. Because accepts this thing accepts an RNG and gives you this, so this qualifies to be a run of A. Okay, so non-negative in is a run of A. Okay, negative, non-negative less than using flatMap non-negative in. Where is flatMap? Oh, you hear this, and then a function from A to run B. So non-negative in, and we put these things like JavaScript. uh, but this is the last. They have a special notation for this. This one. Where is, where is it? Then the function, because this thing will take care of wrapping the stuff in the LMB.
about equals a. If oh my god, no, this is hard. This should be marked as hard. I don't know what to put in here. I don't know if this it's alright. Because what's this two? I don't know. I don't think this is going to make it. because we have just to write in a thing. One find choose. Uh, so I'm starting to understand this, but at this point, it won't find in here this fellow. Mm-hmm. You see? So somehow we. I think we exhausted the time. Just 6 minutes more, 10 minutes more. We have people in here. I don't know how to pass this thing over here because I am constrained with this solution. Perhaps we should implement it by ourselves. If we do, it won't compile either because of the RT, or it will become uh, infinite recursive, you know. This these are the results that we were seeing here, 7, 7, 4, 9, and -9. So, but yeah, it's cool. But to be honest, I'm not sure what machinery came into place in here, because there is no. For me, sounds more like infinite recursion, unless it stops. at some point in this condition. Other than that, yeah, isn't the number. We were able to solve it, but there is an obscurity for me in here, which is going to be clear when seeing the answers. But yeah, thank you very much. I didn't expect to solve this one. You know, how difficult could be writing compilers? I'm asking myself, like the one used by Scala. How much mathematics are in, are in there? I mean, it's like a great area of study, but like could take your entire life. So, and I need a job, like an income, so I can, in my spare time, continue with this computer science, even with going deeper and deeper into the topic of programming languages, the theory, and then other stuff. For the time being, thank you very much. 1 hour and 20 minutes. See you maybe tomorrow. I'm not sure. Uh, have a great night.